Unit 3, Day 20 Notes, Part 6. This will be the last part. Alright, so here, we're given graphs of two functions. We're given a graph of the original function f of x and the graph of original function g of x. So the first thing tells us, hey, let p of x be the ratio of f of x to g of x. Now they're asking down here to find the derivative of p when x is 5. So the first thing I have to do is find the derivative of p of x. Obviously, I have the ratio, so I'm going to use the quotient rule. So let's do that right now. Okay, so Hody Hi minus Heidi Ho all over Ho Ho Ho. So now let's substitute wherever I see an x, I'm going to substitute in 5. Okay, so let's first find the value of f of 5. So there's 5. So f of 5 is going to be right there. And that looks like it's negative 3.5. And then g of 5 is going to be right here. And that looks like it is at 5. So let's substitute those values in first. So again, when we say g of 5 was 5, I replace the g of 5, I'm going to put in 5, and f of 5 is negative 3.5. So now we got to find the derivative of f and the derivative of g when x equals 5. What is that? That's the slope of the tangent line. So this is a straight line, so it looks like the slope of the tangent line is down 1 over 2. So that's going to be 1/2, and it's going down to the right, so it's going to be negative 1/2. I'm just going to write that here so I don't forget. And then, ooh, another line. So it looks like I go up 1 over 1. So slope is going to be 1 right there. So derivative of g at 5 is 1, and the derivative of f at 5 is negative 1/2. And once I substitute those in, now I can simplify. And we can do this 5 times negative 1/2 is negative 2.5 plus 3.5. Hey, that's going to be 1. 5 squared is 25. So the derivative of p, or p prime at 5, has a slope of a tangent line that's 1/25. Now let's look at the next question. I think it's over here. Yeah, sorry, right below it. Find the equation of the line tangent to the graph of p of x when x equals 5. So we just found that the derivative, I wrote p of x, it should be the derivative of p at 5, so p prime of 5. We just found that that's 1 over 25. I then know, so this is my slope of tangency. P of 5 is going to be my point of tangency. That's f of 5 over g of 5. And when we did that before, we found f of 5 was negative 3.5. G of 5 is 5. And I get negative 0.7. So 5 negative 0.7 is my point of tangency. And now for the equation of the line, it's going to be y minus y1, which will be y plus 0.7, equals the slope times x minus x1. And that is the equation of the line tangent to the graph of p of x when x equals 5. All right, so now we're going to do the same thing, except now we have r of x, and they give us the numerator sine x, but we still have to use um, f of x for our denominator. So let's go through and do the same thing. Take the derivative, and we'll see where we are. Okay, so Hody Hi minus Heidi Ho over Ho Ho. This is what we get. And now I got to find some information. Now we're at 0. So f of x at 0 is down here, and it looks like we're at negative 5. And, um, and that's where I am right there. And over here, when we are at 0, it looks like, no, g of x. We don't have a g of x here. Sorry, we don't need that. All right, so let's substitute in what I know. All right, so I put in 0. So we said f of 0 is negative 5. Cosine of 0 is 1. Sine of 0 is going to be 0. 0 times anything is 0. So I don't need to find the derivative of f at 0, because that's going to end up being 0. And we just said f of 0 is negative 5. And then I'm going to square it. Negative 5 times 1 is negative 5. Negative 5 squared is positive 25. So I'm going to find the derivative of r at 0 equals negative 1/5. So we're going to need this slide down a little bit. We're going to need this to find the equation of the line tangent to the graph of r of x when x equals 0. So once again, we just found um, r prime of 0 is equal to negative 1/5. That is our slope of tangency. And now I'm going to plug in 0 into the original function, and we get sine 0 all over f of 0. Um, we knew f of 0 is negative 5, but it doesn't really matter because sine 0 is 0. But the only thing we would check was to make sure the denominator is not going to be 0. So it's 0. So 0, 0 is our point of tangency. And now let's put this into the equation of a line. Y minus 0 equals negative 1/5 times x minus 0. Okay, we could leave it like that. If you wrote it as y equals negative 1/5 x, that is also correct. Okay, last page. All right, let's go on to the last page here. All right, so we're given a table, and we're going to answer some questions, and we're going to need some of the information on the table. So the first thing says, estimate the value of the derivative of g at when x is 2.5. So I don't know what that is. So let's go back to what our slope formula was to be able to estimate the derivative. Again, derivative slope of the tangent line. So we're going to use the secant line. We're going to use a little bit to the left of what the point is, 2.5, and a little bit to the right. So these are the points on the function that are a little bit left, a little bit right. And again, it doesn't matter what the function is. So if I'm trying to find right here, this tangent line, well, I'm going to cheat a little bit, and I'm going to use this point and find the secant line. And we're going to say, hey, that's pretty close of an estimate for what the tangent line is. So let's look at the table and fill in those values. And using those values in the table, we find out that a good estimation for the derivative g at 2.5 is negative 2. All right, now, if p of x equals g of x over f of x, what is the value of p prime of 4? What does this value say about the graph of p of x when x equals 4? Give a reason for your answer. So I need to find the derivative using the quotient rule, and then I need to put in let x equal 4, which is going to use that top row of the table. So taking the derivative, we get ho-de hi minus hi-de ho over ho-ho. And now I'm going to put in let x equal 4. Okay, and now using the table, all of these values up here will fit into one of those values using the quotient rule. So let's put those values. And putting those values in, we get negative 2 minus 56 over 1, which is negative 58. So that's what the derivative is at when x equals 4. And since we know that it's negative, so since p prime of 4 is less than 0, then the graph of p of x is decreasing at x equals 4. All right, just 2 more questions, and we're done with day 20 notes. All right, 2 more questions, still using that table up above. And here, interesting question. So we have to find what the value of the derivative is. So to take the derivative, what I need to do is I need to treat this like the product rule. Let me get another color here. So the first term is 2x squared, and the second term is f of x over g of x. So it's the derivative of the first, so that'll be 4x, times the second, f of x over g of x, plus the first, 2x squared, times the derivative of the second. So only this one part, I have to use the quotient rule, ho-de hi minus hi-de ho over ho-ho. So it's going to be the ho is the low, so that's g of x times f prime of x minus, I had to erase that too far in, minus the numerator times the derivative of the denominator all over the denominator squared. Okay, and now I'm going to have to use my table, and let's substitute all these values in for g prime of 2. And I'm going to do that right now. Okay, and when I substitute all the numbers, every place C and X, I put in 2. And from the data table, these are all the values I get. And we get g prime of 2 equals negative 16 plus negative 56, which is going to equal negative 72. Okay. All right, last question. Find the equation of the line tangent to the graph. So first thing I can do is find the point of tangency. And again, it's when x equals 3. So I'm going to do v of 3. This will give me my point of tangency. That's going to be 3 times 3. And g of 3 is negative 3. So 9 over negative 3, which is negative 3. So the point of tangency is 3, negative 3. All right, so I got my point. What else do I need? I need the slope. How do I find the slope? I find the derivative. So I'm going to end up using the quotient rule. And let me save some space. Sorry, that first one took too much space. I'm going to use the quotient rule, and then I'm going to find the slope, and I know point and slope. I can put into the equation of a line. What's the derivative equal to? It's Hody high. That's the low. So it's g of x times the derivative of the numerator minus the numerator times the derivative of the denominator, Heidi ho, all over ho ho. So there's g of x all squared. Let's put in our values there because we're trying to find when we're at x equals 3. So now every place C and X I substitute in 3. And sometimes I got to use the data table. So g of 3 we said was negative 3 times 3. 3 times 3 will be 9. G prime of 3 is 6. And as we said, g of 3 was negative 3. So let's simplify this. I'm going to get negative 9 minus 54. It's going to end up being negative 63 all over positive 9. So v prime of 3 is, let me just write that out, negative 63 over 9, which is negative 7. And that's only part of it. This is my slope of tangency. Up above, as I said, there's my point of tangency. So the equation of the line that is tangent to the graph will be y plus 3 equals negative 7 times x minus 3. All right, and that completes day 20 notes. Good job. Sorry about the long video.